Hello, this is Group 8, and we did our project on teaching AI to beat the world's hardest game. And my name is Tim Fassel.
It's Brandon Mercilani.
Amir Al-Shatri.
Turkey Lotation.
I'm Nicola.
Okay, in this project we worked on creating an intelligent program to play the world's hardest game. The game consists of several levels that have different difficulty to make it more challenging, starting with programming in Python for the game and processing for AI. We use genetic algorithm and reinforcement learning to program the intelligent agent for playing the game.
So the world's hardest game is a 2D game developed back in 2008, and the basic goal of the game is to get from point A to point B. A player is a red square starting in the green area on the right, and you have to go to the green beacon on the other side by avoiding all the blue circles, which are your enemies. Well, in the original game, there's about 30 levels designed, and each level is more complicated as you progress.
So we used a couple different languages for this project. Initially, we started out with Python. We used this language to design the game that was actually played by us, a user, and that we used that to help us plan how we wanted the game to look. And then we later switched to a language called processing, and we used that for the rest of the project, including coding the AI. So I'm going to briefly go over what is processing and why we chose to use it. Processing is a programming language that's based off of Java, and it allows users to code within the context of visual arts, and it has been specifically designed to provide instant visual feedback. We use this language because while we were doing research for the use of AI in video games, we found that many developers ended up using the processing language instead of Python. This allowed us to have more resources to look at and use for our specific project, and it made an easier time interfacing the AI within the game. And now we're going to show a demonstration of the game in Python just so you can get an easier understanding of it. Which is here. This is the general gist of the game, where you just move around, have to avoid the blue circles. If you run into it, you lose. If you get all the way to the green box, then you win. And this is Abby.
In the second level, the count of blue balls is increased, and the movement of balls are in more complex fashion. Some balls are added for more added complexity for the users, just to make it more interesting and to add more challenge for the player or for the users.
Yeah, this level was coded in Python, played by a user, not an AI. And then related work, this is what we took a lot of the references from when we were designing our program. This was designed by a famous YouTuber who goes by the name CodeBullet. In his program, he uses a genetic algorithm to have 1,000 dots that you see down here, and they try to find their way up to the red dot. And then I'll play the video showing just a quick example of that. And the AI used in this is largely what we use in our program because it's pretty simple and versatile, so it gets the job done that we need to do.
To make the artificial intelligence work for our specific purpose, we used genetic algorithm and reinforcement learning. So for the genetic algorithm, each generation creates a population, which is a set number of squares, and each one of them works independently to find a possible solution to our problem. Every square moves in a random direction, changed every generation by the mutate function, which takes the information from the parents and randomly changes the direction it mutates the genome of the square in order to test for a new and a possibly better result. For the reinforcement learning, we use fitness as a reward. Fitness is calculated for every square, each and every generation. It is calculated in two ways. First one, if the square gets to the finish line, its fitness is based on how many steps it took to get there. And if the square does not reach the finish line, then the fitness is based off of the distance to the finish line. And after one generation is done, the square that has the best fitness, based on the amount of steps it took and the distance to the goal, gets chosen as the best solution for the generation. And we just decided not to use the negative side of the reinforcement because we think it would not make a difference for our purpose.
So these are some of the results that I got when I ran the program for 50 generations. I ran it with 1,000 squares going at once and versus 100. And as you can see, the 1,000 players in blue finished it significantly faster. I think they finished it in around like 15-ish generations earlier than the 100 players. They started out with more steps taken, but they quickly dropped to a lower amount and stayed to the lower amount compared to the 100 players. And this is a table and data chart of the amount of generations it took for the 100 players to finish. And it is a little sporadic, ranging from the lowest being 7 generations to the highest being 28, but they hover around like in between 10 to 20, with the average being 15.
So for the first level, we modeled it after the real game with some changes. So it creates 1,000 red squares. Then after each run, it turns green, representing the best previous run. They it's a blue circle, they die. In the top left, you can see the generation and how many steps were taken to reach the goal. Here's a video showing it in action.
Yeah, so as you can see in this video, each generation, the squares get a little more efficient, a little more grouped up every time. So they'll go from very sporadic random movements to more refined straight line, start straight to finish.
So this is the second level that's using our AI, and it's modeled after the level 7 of the actual game. It has a little bit more space and more enemies, so it's a little more difficult for AI to find a solution, but it still works.
One of the shortcomings we had with the project is that we had to recreate the game ourselves in Python and process. We also had a problem where it didn't play the original browser game, so some of the features are missing from the game. Also, it has limited capabilities that it can only navigate through a second level, a 2D level, to reach the goal location, and it's not as smart or fast as it could be. Some future improvements we could add to it is to configure it so that it could be able to play the real game on the web. And we can have it implement incremental learning to allow the AI to become more efficient with its steps. And we can also allow the program to know when it's no longer making improvements in the program. And then we can make it able to play other games as well.
For the conclusion, we programmed the world's hardest game in Python language, created an intelligence agent using processing language to play the game based on AI genetic algorithms and reinforcement learning, comparison and analysis of learning the gameplay by the AI agent based on different plays.
And this is the contribution slide where we just go over what each person did throughout the project, summarizing and breaking down what we all did. Personally, I kind of spearheaded the coding and processing and then handed it off to my group mates to specifically adjust and help bug fix.
Assisted with, ups for some ideas with the project. Also helped find some bugs and fix them. And also found ways to make the effectiveness of the algorithms better.
I designed another level that could work with the artificial intelligence that we created, and I cooperated with my teammates on testing the program, and we all worked on making some important decisions regarding our project.
We designed 2 more levels using Python programming code, and we add some challenging to make it a little complexity, and such as like increasing the speed or adding more balls or moving balls, and working with the group on their programming and presentation as well.
And then this is our GitHub links. The top one is to our code, and the bottom one is the one I mentioned before that the YouTuber made where he had the dots trying to get to the red dot. And that is our presentation. Thank you.